So following on from the previous video, we were trying to sketch this function here, and we got to a stage where when x is very very big, when x is heading towards positive infinity, this term will dominate, meaning it wants to do this. Okay, and then when x is heading towards negative infinity, this term here dominates, so it wants to do this when it's big. And note that because the 2 here, this is a lot steeper than this, meaning that the steepness here is it's a lot steeper here than it is here. Okay, so this, yeah, so just bear in mind that because there's a 2 here, this side here will be a lot steeper than this side here. And when x is 0, when you put 0 into this whole thing here, when you put 0 into this whole thing here, the intercept will be -1. So we guess that it would do something like this. Okay, so we guess it's going to do something like this. The next thing to do is find out the critical points. So we want to find out where, if there, or where the gradient of this line will be 0. So we've got to differentiate this. So now find f prime. So starting with your function here, differentiate it. It will then give you this. Okay, and then now try to find out when the gradient here will be 0. Okay, when will this be 0? So you will have to solve this. When will this thing here be 0? So you will have to solve this. You see, trying to solve this, if you try to make x a subject here, it's actually quite difficult. See if you can do it. Try to solve this. Think about it. Press pause and have a go. Try to make the x the subject of this. It's actually quite difficult. You're going to have to use a technique which I haven't shown yet, but try to do it so that you can see where the problem lies, why it's difficult. Try to make x a subject here. Press pause and have a go. Okay, so really to do this here, if you try to make x a subject, it's actually very difficult. So what we do is we use this technique here, where you use this technique quite a lot. You turn this thing here into a quadratic equation and then try and solve it. So so here the trick, this is it's just a trick. So let u equals e to the power of x. So basically turn this thing here, turn this thing here into a quadratic equation. Solve the quadratic equation and then turn it back into this thing. You see what I mean later. So we're going to let u equals this thing here. Okay, so that means this, remember, this here equals u. Okay, so this here becomes u. Okay, and this whole thing here actually becomes this, because wait there, if you look at u is this thing here. Hang on, if you look at u, this u is this thing here. Okay, if you power, remember that this is u here. If you power this to the -1, then this thing here is really in effect e to the power of -x, because x to the power of a to the power of b, you get this times this. So well, if you want to rewrite this here in terms of u, if you want to rewrite this in terms of u, you will have to do this. U to the power of -1, so that will then give you this thing here, and then you've got to times it by 2. So the point is that if you want to, if you let u equals e to the power of x, this thing here will become this. This thing here will actually become to the power of -1. Well, this thing here will become this thing here. Okay, and then leave this 3 as it is, because we are letting u equals this. Well, if you let u equals e to the power of x, this whole thing here becomes this. Okay, so now it's a matter of solving u. When will u equal 0? And then later we will turn the u back into the x. Okay, so when you're trying to solve this, let u equals e to the power of x. That will then take you to this. Okay, so now hang on. So now that you're here, so we are trying to solve this now. Try and solve u now. So let's turn it into a quadratic. So here you've got this block equals this block plus this take away this, times everything by u. Okay, so 0 times u will be 0. U times u will be u squared. This thing times u. So you've got 2, times u. Then these two gets added together. That would just be this. This times u will give you this. Now factorize. So that will then give you this. You see, u equals 1, 1 and 2 here. So when you put 2 into here, this whole thing will be 0. When you put 1 into here, this whole thing here will be 0. Okay, so the answer here is u equals this and this. Okay, and remember from earlier we said let u equals this thing here. Okay, but don't forget. So now that you've got u equals this, you can set u. Well, remember, looking at this here, if you put u equals 2, then the whole thing here is 0. So the trick here is to set. So remember, u equals 2 here. That would be when the whole thing would be 0. So let's turn this to, well, u equals this. So turn it. So do this. Hopefully you can understand why you have to do this. Well, 2, now take the natural log of both sides. That will then give you this. So x here equals the natural log of 2. The trick is trying to understand why you can do this here, but you can't do this. Okay. When you do this here, take the natural log of both sides. That will then give you this. You see, when you make x to be the natural log of 2, then this whole thing here will be 0. When you make this, if you put the natural log of 2 into here and into here, then this whole thing here will be 0. Okay, but translate this into a quadratic. Okay, into this here, and then slowly solve the u, and then turn the u back into the x by doing this. Okay, and don't forget our other solution was 1. So now set 1 to be to be this thing here. So that will give you this. So we've got two solutions, this and this. So what that means is that when x equals the natural log of 2 and the natural log of 1, that's when the gradient will be 0. Okay. So by the way, this here is 0. Okay. This here is 0 because natural log of 1. If you draw the if you do this here, this here is 1 here. So then this thing here will be 0. Okay. This thing here actually equals 0. So when you look at the graph here, we know that the gradient here will be 0. We know that the gradient somewhere along the natural log of x will be 0. We just don't know where. Maybe around here, maybe down here. But all that we know, maybe it's going to do something like this. The gradient will be 0 at natural log of 2. So maybe the gradient is 0 here, and then the gradient we know is 0 here. So maybe it would do something like I don't know. Well, the gradient may be down here, so it may be doing something like this. Okay, it may be up here, so maybe it may do something like this, and then something like this. But the point is that the gradient will be 0 somewhere along here. Okay, and then the gradient will be 0 dead on x equals 0. Okay, and we want to now find out where the gradient will be 0. Is it up here, here, or is it down here, or where? So we got to put this back into here, and then into here, and then into here. So when you do this here, when you put the natural log of 2 into the original function, it will give you this, blah blah blah, blah blah blah, blah blah blah. It will give you this. Okay, so roughly around here, it will give you this. Okay, so we we now know that the derivative will be 0 at this point here. Okay, meaning that that our point here, this here, right here, is when the gradient will be 0. This here. Okay, don't forget this value here is lower than the 1, because if you look at this here, this here is lower than the 1. Okay, so going back to our graph here, it's this bit here is lower than the one here, than the negative one here. So our graph will have to do this, and then it will have to go up because this here is lower than the minus one. So it has to go up and then back down again. Okay. So far our graph will do something like this: up and then down again. Okay. So now we need to consider the inflection point. Okay. So we're going to look at the second derivative of this, which will be in the next video. Okay.